Hi, this is Mr. Block from Mr. Block Tutors Math. Today we're going to look at exponentials and logarithms. And we're going to see that there are two ways of writing kind of the same idea and how we can solve logarithm problems by changing them to their exponential form. So let's do that. Let's get a whiteboard here and we'll just do that. So a log or a logarithm is the exponent needed to raise the base to a certain number. So here I'd read this and it'd say log base 2 of 8 equals 3. Doesn't really make much sense, does it? In exponential form it makes sense. 2 to the third equals 8. So 2 to the third equals 8. I use that little loop there to kind of help me do that. You could have written it like this and said, maybe this might be a problem. Log base 2 of 8, and it just says evaluate it. What is that? Or it could have put it in equation form, like that. Then you'd say, well, 2 to the y equals 8. And then if you know your powers of your smaller numbers, like 2 to the first equals 2, 2 to the second equals 4, 2 to the third equals 8, and so forth. Let's just do one more. 2 to the fourth equals 16. Then I know that 8 is 2 to the third. And since 2 equals 2, then y equals 3. So log base 2 of 8 is 3, which is the same thing as 2 to the third equals 8. This is exponential form. This is log form. Okay, let's do another one of those. Same idea, put it in exponential and log form here. Let's just erase some of this. So what if we had something like this? Here, you try it. Log base 5 of 25. What is that? Well, it's obviously 2 because 5 to something equals 25. So that something has got to be 2, right? Question mark has to be 2. Let's take one where it's a little bit different. Let's take this log form, log base 10 of 0.1 equals -1. Put that in exponential form. 10 to the -1 equals 0.1. It's easy to see. 10 to the -1 equals 1/10 equals 0.1. How about something like this? What is the log base 2 of 1/8? Put it in exponential form. 2 to something, I'll just make that an x this time, equals 1/8. 2 to something equals 1/8. But 1/8 is the same thing as 1 over 2 cubed, which is the same thing as 2 to the -3. Since 2 equals 2, then x must be -3. Now, we can use this idea of interchanging the log form and the exponential form to solve problems. Like, for instance, suppose I had this problem. log base 3 of x equals -2. What's x? Well, put it in the exponential form and it should be obvious. 3 to the -2 equals x. 3 to the -2 is 1 over 3 squared is equal to 1/9. Here's x. So the point I keep trying to make over and over to you is that the log form switch to the exponential form. It'll be easier to work in the exponential form. Or suppose I had something like this. Log base x equals 4, or of 4 equals 3. And that's a pretty hard one to think about. X to the third equals 4. X to the third equals 4. Now, what will that be? Well, if we take the inverse operation, the cube root of x cubed is x, so there's my answer, the cube root of 4. And if we go one more step with it and do that out, I'd get the cube root of 4, cube root of that, 1.5874. About 1.5874. Let's do a couple others before we quit. What if I had, say, the log base 8 of 4 equals x? Once again, change it to exponential form. So 8 to the x equals 4. Now, if you know your powers, 2 cubed equals 8, and 2 squared equals 4. So, whoops, I kind of got off there. Let's change it. That's 2 squared here. So this would be 2 to the third to the x, and this would be 2 squared. So this is 2 to the 3x equals 2 squared, and since 2 equals 2, then 3x must equal 2 here. Divide by 3, x equals 2/3. So the log base 8 of 4 equals 2/3. Let's check that. Let's check that using exponentials. So 8 to the 2/3 equals 4. So this would be the cube root of 8 squared. Cube root of 8 is 2. 2 squared is 4. Check. Works.